So today we discuss the magnetic properties of material. Okay, so the very important magnetic properties of material. There are the three types of material: diamagnetic material, magnetic material. Second is magnetic material, and third is ferromagnetic material. There are the three types of material we study here. Okay, and there are some parameter. Okay, there is in discussing previous class. There is a one parameter we discussed is chi. Okay, that's the magnetic susceptibility. Okay, a very important factor. There's a chi, and another that is the mu zero. That is relative magnetic permeability. Relative magnetic permeability. Okay. Okay. So that is a mu r, and mu zero we know that is magnetic permeability of free space. Okay, we know that. And here another factor H, that is the field intensity, magnetic field intensity. Field intensity. Obviously, there is a magnetic. Okay, there is a magnetic. Now, these are the parameter. What is the relation between these two? Okay, or parameter. How to define this? Greater than, less than. Okay, for suppose here, suppose call a chi. Okay, the magnetic susceptibility. Okay, the magnetic susceptibility is less than 0 for diamagnetic material. Short form. Paramagnetic PM, ferromagnetic right FM. Okay, when you write FM, that means a ferromagnetic material. Okay, so and this chi is greater than 0 for paramagnetic material, and chi is much greater than 0 for ferromagnetic material. Okay, that's very important. And now there is some table for next page. Suppose a table here. So diamagnetic material for paramagnetic material, and there is a ferromagnetic material. Okay, so for diamagnetic material, okay, the chi is less than 0, and chi also greater than -1. Remember that. Okay, and the chi obviously greater than 0, obviously greater than 0. Okay, greater than 0 and less than of epsilon. Now what is epsilon? Is a very small positive value, very small positive value. Okay, very small positive value. And for ferromagnetic material, is chi is much greater than 1. You remember that. For diamagnetic material, okay, and that is mu r, we discuss in here that mu r, relative magnetic permeability for diamagnetic material, okay, that is a mu r, okay, is less than 1. Okay, and also greater than equal to 0. Okay, and for paramagnetic material mu r, the relative magnetic permeability is less than some epsilon plus 1, but also greater than 1. Okay, and for ferromagnetic material, the relative magnetic permeability is much greater than 1 for ferromagnetic case. And for diamagnetic material, okay, this diamagnetic material, mu magnetic permeability is obviously the less than mu naught, the free space. Okay, for paramagnetic material, mu is greater than mu naught, and case of ferromagnetic, there is also mu is greater than mu naught. That's for the some relation, the comparison between the diamagnetic, paramagnetic, ferromagnetic, magnetic material in terms of chi, mu r, mu and mu naught. Okay, and one thing is keep in mind that is a magnetic material. Is any magnetic material easily magnetized when you place an external magnetic field, because the magnetic material is grab that magnetic field from that external magnetic field. Okay, so remember that when we uh, magnetic material magnetic material magnetic material in external magnetic field external magnetic field obviously. Okay, magnetic field, and these magnetic material easily magnetize them. It's easily magnetize. Okay, now here we discuss the difference between diamagnetic, paramagnetic and ferromagnetic material. Okay, and keep in mind that you get a one or two short question, suppose 2 marks or short question you get from what is the dielectric paramagnetic material and what is the ferromagnetic material, what is the some inside some key point question here. Okay, you get this type of question in board exam. So here we discuss the difference between diamagnetic, paramagnetic and ferromagnetic. Difference between diamagnetic, paramagnetic and other is ferromagnetic. Okay, and first point, okay, you remember that the point number one, first point, diamagnetic substance are very weakly repelled by the magnet. Okay, in case of diamagnetic substance is weakly repelled by a magnet. Okay, by a magnet. But in case of paramagnetic material, so in case of the paramagnetic material, they are the attract, okay, but weakly attract by magnet. Okay, but in terms of ferromagnetic material, okay, that's the terms of ferromagnetic material are strongly attract. Okay, that's very important. The ferromagnetic are strongly attract, and the paramagnetic they attract also, but they are the very weakly. Okay, and that case of diamagnetic material, they are weakly repel actually. Okay, that's a key point here. Diamagnetic here is a weakly repel. Okay, and another point. Suppose point number two, in case of diamagnetic material, okay, when a diamagnetic material place an in a magnetic field, in a external magnetic field, okay, and they acquire the magnetism, okay, they acquire the magnetism, but the direction is opposite of the magnetic field. When we place a diamagnetic material in external magnetic field, they get magnetism. Uh, Actually, weakly magnetism, but opposite direction of the magnetic field. But the important word, opposite direction of B. Suppose there is a material here, the B in that direction. So here is the magnetism direction, opposite direction here. Okay, but in case of paramagnetic, okay, in a paramagnetic material, they also get a weakly magnetism. Okay, feebly magnetism. Get get weakly weak magnetism. To get weak magnetism. Actually, the weak magnetism. Okay, there is a weak magnetism. Okay, but the direction is the same. But the direction be the same. Okay, so the material here be in that direction. Obviously, that direction magnetism both are in same direction. But third, three is a gate of the not with a strong magnetism gate, ferromagnetic material gate, strong magnetism. Okay, and the same direction in same direction of B. Okay, so means there is a very strong direction. Obviously, the B in same direction. Okay, so very strong. Actually, here you get a not strong. Is a very strong. Okay, there's a and that another point we discuss here is the color number 3 difference. Okay, suppose the material, okay, diamagnetic material, suppose placed in a magnetic field. So placed in a magnetic field, and that magnetic field avoid to that material. Try to avoid the B. Try to avoid the diamagnetic material. Okay, but in case of paramagnetic material, okay, they obviously uh, these are the material, okay, and that we not avoid, we almost, okay, they do not avoid these. The field is attract to a field is attract towards the material. Field is attract towards the material. Okay, but in case of ferromagnetic, these are the diamagnetic material, these are the paramagnetic material, and that's the case of ferromagnetic material. Okay, these are case of ferromagnetic. So B obviously is called B. Okay, strongly attract towards the ferromagnetic material. Strongly. You are the strongly attract towards the ferromagnetic material. Okay, and there is another point. Suppose number 4. Okay, suppose uh, that is B in that direction, suppose B in that direction, magnetic field, and then in case of suppose both cases draw B, and here B, three cases are B in same direction, but the material, okay, that's diamagnetic material, the material is perpendicular to the B. Diamagnetic material is perpendicular aligned to the magnetic field B. In case of paramagnetic material, okay, this is also the parallel to the field. These field are the obviously external field. Okay, remember that these are the external field. Okay, this is a case of paramagnetic material is also parallel to the field, and in case of ferromagnetic material, okay, these also the parallel to the ferromagnetic material, also parallel to the field. Okay, but these are the strongly, weakly, and obviously they are the perpendicular. Okay. Number 5. Okay, weakly repelled by the magnet, diamagnetic material, by magnet. Case of diamagnetic material. So case of paramagnetic material. Okay, case of paramagnetic material, weakly attracted by magnet. And number 5, strongly attract. Strongly attract. Okay, that's case of paramagnetic. Okay, and number 6. Okay, move strong field to weak field. This diamond move strong to weak field. And number 6, in case of paramagnetic material, okay, paramagnetic material move weak field to strong field. Weak to strong field. And case of ferromagnetic material, move weak to strong. Strong means a very strong field. Okay, number 7. Okay, lost their magnetism when we remove the external field. Okay, when remove external field, they lost their magnetism. Okay, but number 7. Okay, okay, yeah, we the same, lost their magnetism, same. Their magnetism for same circumstances. Okay, when remove the field, but in case of ferromagnetic material, okay, these are the ferromagnetic material, they have permanent magnetism. Okay, they have permanent magnetism. Okay, now last term is the example. Okay, there are some example we discuss here, and suppose there is an example. Okay, and suppose there is the called water. Okay, and copper, gold. Okay, these are the solid state, liquid state, and gaseous state. Okay, these are the 3 states here: solid, liquid, and gas state. This 3 states belongs for diamagnetic material. Okay, but in case of paramagnetic material, Okay, they also solid, liquid, gases. They also solid, liquid, and gas. Okay, example is called aluminum. Okay, platinum, sodium, and the ferromagnetic material. Okay, ferromagnetic material is a strong and only state is solid state belongs to, and that is iron, nickel, cobalt. These are the strongly paramagnetic material. Okay, and here we discuss some another 2 or 3 points here. The magnetization of magnetic material. Okay, they are the inversely proportional of absolute temperature. Okay, some magnetization of paramagnetic material. So magnetization of paramagnetic material. Magnetization of paramagnetic material. Magnetic material. Okay, paramagnetic material is the absolute temperature, means inversely proportional to the absolute temperature. Temperature. Okay, that is the aim. Okay, and that is equal to some constant C, and that is B naught by T. And what is C? C is the Curie's law from Curie. Law. That's called a Curie's constant. Okay, and that is chi also related to C, that is equal to mu naught by T temperature. So that's for paramagnetic material. Okay, but ferromagnetic property depends on temperature. At high temperature, ferromagnet becomes a permanent magnet. Okay, for ferromagnetic properties is for magnetic. Okay, and at high temperature, at a very high temperature, okay, that ferromagnets become permanent. Become permanent at very high temperature. Okay, and the temperature transition, and these temperature transition, okay, from ferromagnet to paramagnet, from ferro to paramagnet. Okay, and that temperature is called Curie temperature. The temperature called Curie temperature. Okay, that is chi, that is equal to C, the Curie constant, by T minus Tc, Curie temperature. Okay, and T is much greater than Tc. Remember that. Okay, that is the basic, that is important. Okay, what is Curie temperature? And now we discuss another important concept, the hysteresis of the ferromagnetic material. That's very important. Okay, that's the hysteresis of ferromagnetic material. Okay, and that's very important. That is actually BH graph. Here is a B, magnetic field, and H is the magnetic field intensity. Okay, both are obviously vector. Okay, and here is important. Okay, from that is 0 point. Okay, that point is 0. And 0 point when you get a no current. Okay, there is no magnetic field here. Okay, that's why it is called a 0 point. When that is a magnetic material placed inside a solenoid, so and this get for a magnetic field or magnetization. Okay, so if B also increase at a certain time, B increase at certain time, okay, B increase at the point, this point is called A. Okay, and these material will get a magnetic field and also get a magnetic field intensity, that is from 0 point to A point. Okay, after point A, when becomes H becomes 0, after point A, when H becomes 0 but B is not 0. Okay, after the increasing H, now we decrease the H magnetic field intensity and becomes 0, means that this line y-axis line, okay, here will the H be the 0 and here B is not equal to 0 at that point. Suppose that point, okay, this point, okay, this point, okay, where that is H0, H equal to 0 but B not equal to 0, and suppose we get suppose 1.2 Tesla. Okay, and this point is called retentivity of resonance, and this point is another name. This point is the name is retentivity of, okay, this point. And here the graph now look like this. Okay, now further reduce H. Okay, when H becomes a minus, then we get a magnetic field B with a 0, and further reduce at some point, suppose at that point where B equal to 0. We know that x-axis in value of y, okay, y value on x-axis is 0. So at that point, okay, B equal to 0, okay, B equal to 0 but H equal to some minus value, okay, suppose minus 90 ampere per meter. Okay, and this point has another name is called coercivity. This point is called, suppose this point is called coercivity. Right. Okay, now further reduce and now turn the current in, suppose in reverse current. Okay, in case of reverse current, here is a minus H, obviously here is a minus B. Okay, in case of reverse current, further reduce, so in terms of reverse current, in case of reverse current, suppose at that point, suppose here, okay, is a current in negative direction. This is a reverse current. In case of reverse current, there's a reverse current at that point. Here is saturate. Here now these are the saturation. There is a saturation, reverse current here, saturation. Okay, now, okay, if a reverse current, now, okay, the reverse current is increase. Okay, here actually the reverse current with a increase. Suppose at point A, this point is called a B point, and point B is called a retentivity of resonances, and now this point is called point C is called coercivity, where B equal to 0 but H is negative. Okay, magnetic field is negative. At the point is D, this D point is saturation when reverse current is increased. Now when reverse current is decreased, after saturation reverse current is decreased, so reverse current is now decreased. So if reverse current is decreased, okay, if that is reverse current is decreased, now the graph, back to this. Okay, and further decrease, go to E point, and further decrease and go to point. Further decrease, go to point A. Suppose the decrease, go to point A. Okay, this point is E. Go to point A, and you see that it's a input and output both are in different paths. Okay, and you see that curve OA, okay, does not retrace itself by reduce the B. Okay, and this is a unique pattern. Obviously, there is a unique, but depends on the previous condition. Okay, that's very important. But pattern obviously unique, but depend on the previous history of the sample. This phenomena is known as hysteresis, and hysteresis means the lagging behind. Okay, so what is the hysteresis? So hysteresis means, okay, the curve, suppose the OA curve, that OA curve, okay, the OA curve does not retrace okay itself. Itself, okay, on H is reduced, on H is reduced. Okay, here we see that is H, for H value is here on the A point A. Now if H is reduced, now it tends to, if I same path, then B be the 0, but when H be the reduced but B not equal to 0 here, there is some value of B here. Okay, but H is reduced, okay, the B is not unique. Okay, but depends on the previous history, but depend on history of the sample. Okay, of the sample. Okay, and these phenomena is known as hysteresis. Okay, means the lagging behind. Hysteresis means lagging behind. पीछे पड़ जाएगा. Okay, clear? So that's the end of our chapter. Okay, magnetism and material. And next class we discuss a new chapter. Okay, here actually the summary of this lecture. Here actually we discuss that diamagnetic material, paramagnetic material, and ferromagnetic material, and there are some properties, and there is some relation between or difference between these three material. What material you use for making a magnet or not making for magnet, how they relate to when you place in a magnetic field, when, what happened when I remove the magnetic field. Here we discuss all here. Okay, that hysteresis, that's a very important. Okay, that's a very important for board exam. You get a very short question for 1 or 2 marks. Okay, if you have any doubt, please ask in comment section. I will try to give the answer. So next class we discuss the new concept, new topic. Thank you.